Here we have the 2009 projectiles question. A straight vertical cliff is 200 meters high. Here it is. It's 200 meters high. A particle is projected from the top of the cliff. Water or ground underneath. It doesn't say the particle. The speed of projection is 14 root 10. 14 root 10. And if the particle strikes level ground at distance also of 200 meters, just to confuse things, this is 200 meters as well. S of x at this point. Find in terms of alpha. So it's projected here, this alpha is in here. Find in terms of alpha the time taken to hit the ground. Okay, so we need the velocity of y being equal to minus 200 for the time taken to get there. So we'll look at my initial vector. It's going to be u cos a in the I direction plus u sine a in the j direction, which is 14 root 10 cos a in the I direction plus 14 root 10 sine a in the j direction. So I suppose we can start this. S of x is equal to 200 and S of x is equal to ut. So that's 14 root 10 cos alpha by t is equal to 200. So time is equal to 200 over 14 root 10 cos alpha. Sorry, 200 minus, no, 200 over. So S of y is equal to ut plus a half at squared, which is equal to minus 200, and we have minus g, so 14 root 10 sine alpha times 200 over 14 root 10 cos alpha. That's ut minus a half times g times t squared, which is going to be 4 zeros over 196 by 10, which is 1960, and that will be cos squared alpha, and then plus 200 equals 0. So tidying this up, these cancels, I'm going to get 200 tan a. If I divide all these together, well, the 9.8 will come in here too, so this will tidy up nicely. I'm going to get 100 when I type these into a calculator, and 1 over cos squared a is 1 plus tan squared a, and then we're going to have plus 200 equals 0. So I'm going to get 200 tan a minus 100 tan squared a plus 200 equals 0. So tidying it up and bringing everything to the right, I'm going to divide by 100 to get 2 tan a, 1, 1, 2. So I'm going to get, bringing tan squared a to the right, I'm going to get tan squared a minus 2 tan a, and I'm going to get plus 2 minus 1, so that's going to be bringing across a plus 1 to make it a minus 1 equals 0. And this is like x squared minus 2x minus 1 equals 0. Now that to me is quadratic formula. Minus b2 plus or minus the square root of b squared, which is 4, minus 4 by a by c over 2a is going to give me 2 plus or minus the square root of 8 over 2. So 2 plus 2 root 2 over 2, 2 minus 2 root 2 over 2, 1 plus root 2 and 1 minus root 2 are my tan a's. What do we have to find the angles here? find in terms of alpha the time taken for the particle to hit the ground, but we got that, and show that the two possible directions of projection are at right angles to each other. Okay, so they're at right angles to each other. Hopefully the product of these two is equal to -1. Then we can say they're at right angles to each other. We're going to get 1 minus √2 plus √2 minus 2, which happy days is -1, therefore at right angles.